Okay, good morning all. Yeah, my name is Shital. So I am a SE based out of Mumbai and I take care of the networking portfolio in India. So as such, what I'm going to talk about is more onto the technology and not onto the sales angle. This is more to talk about the feature, functionality and what we can achieve with the technology and how we can make the life easy to run the applications. And not only for application, but for the users, for the administrator, everyone who has involved into that. So let me, take some time to speak about why we are going to have this session or what the feature and functionality and how we can tolerate with the today's technology that is emerging on. So if you have seen over the time period, the data center is shifting. So everyone is talking about the cloud, the endpoint is getting changed, they are the mobile device, they are the laptop, PCs and all that. So because of this change, where you have a lot of application coming in the data center or going to a cloud, at the same time the endpoint is shifting, there is a need to change your application delivery platform. So I'm talking about the platform and not only about the controller or the ADC or the WAN optimization and all that. It is a platform which help you to deliver the application, which the people used to have in the data center and they were trying to deliver the application to an end user. But if you see, because of the change in the trend, the requirement of this platform has been changed. You don't know as of today, when you have a lot of traffic that is coming on the device or onto these devices, how is the performance? So the need has been changed. Previously when we used to talk about the ADC or the any platform, we used to say very specifically, I am looking for this much throughput, this much capacity or this much output from a device. Today you cannot predict that. Whenever you launch any new site, whenever you launch the new application, you cannot predict how many users are supposed to come onto the application, right? And that is where we always talk about when you decide on any application delivery platform, it should provide the high performance with respect to a traffic processing, with respect to SSL transaction, with respect to request per second and so on. And when you do this performance analysis, at the same time it should be scalable, and that is what the Ramnan taught about the tri-scale. And we are going to talk into details what is meant by scalability. Is this only a throughput scalability, or is this only a policy scalability, or the anything else? And when you do the scalability and the performance, the functionality should not be compromised. At the hotter the scale that you have, the functionality should remain the same, or you should keep on adding the new functionality. And that is what we feel that now we don't talk about only as a ADC as a technology, but we talk about the application delivery platform. And when you look into all these requirements, basically we are saying that the next era is a technology which has been delivered to deliver all this feature functionality, considering that this is a platform and not only a controller, which controls only a specific functionality, right? It's a platform which is going to deliver the multiple functionality. So let me, go back and what we were talking about the traditionally for the ADC is about the 4 functionality, which is a load balancing, upflow, reliability, and then the acceleration and the security. Now what in the today's session, other than this, the traditional functionality, we are going to talk about the additional functionality, which is a new requirement for your need. So most of the times you will see that the people are coming and talking about the app visibility or identity, where you want to do a single sign-on and keep on adding the solutions into your environment. Or the people are talking about the cloud. When you have a cloud in place, or the people when you want to deliver the application, go into the Amazon or go into the any cloud, the software and so on, you want to ensure that you provide this one as a service to your end user. Whenever there is a demand to deliver any desktop, deliver any application, you provide all this, the service to an end user. So what we are trying to say is with the new platform that we have built up, now the ADC has become a SDC, the service delivery platform, where as and when there is a need to have a service, it can be any service, you should be able to deliver using the same device or the same hardware. And this technology we have migrated from a ADC to a SDC, which is a service delivery platform. So after this session or during this session, we will try to highlight how we will able to deliver the new requirement on the same older ADC platform, and how it can be scaled and how you can manage the visibility, how you can go and the troubleshoot, how you can ensure that the end user is happy and so on. So let me start with the ADC functionality, what has been built over the time period and the people used to have this on the device. So as the Ramnan said, we have 4 major functionality which has been built on the device. One is ability, performance, upload, and security. The new functionality that we are going to talk will also fall under either any of these pillars. But for you, it's only one device or the only one technology which is underlying technology, and then you can keep on adding the services on the top of that. So into this, what we are going to talk about is a traditional functionality. At the same time, when you want to build a cloud infra or when you want to build the enterprise data center and you want to bring the more and more application in the data center, how the device or how the technology can be useful is all about, right? And when we build all this technology on the device, we call this device or this technology as a Nextera, which is all the functionality, all the services which is going to be delivered from the same device or the same platform. So let me take you, into the some of the technical part of the, the traditional ADC, and then we will come back onto the service delivery platform. So as you are aware, we were talking about the availability, the compression, caching, or the, the performance, upload, and then the security. So we covered the most of them into 4 different pillars. So what I'm going to do is, and my team is going to do is, we are going to talk onto the each and every pillar in details, and then during the end of the session, we will have a demonstration of the few of the functionality that we are going to talk about, which is very new in the market, right? So what we believe is the Nextera is the platform which can able to deliver or where you can provision each and everything that you are looking for. It can be for troubleshooting, it can be for delivery, it can be for performance optimization, or it can be to reduce the CapEx and the OpEx types of the scenario. So let me talk about the first functionality, which is the application ability, right? So the application ability is a functionality which help you to deliver or ensure that your application is available to end user, which is 24/7/365 days. It can be from a same data center, it can be from multiple data center, it can be from one ISP link, or even if you have multiple MPLS service provider, we can ensure that the application is available simultaneously on the multiple MPLS service provider. And that is what we do in the application ability. Let me take you, the few details of the application ability. So the first one to cover is the server load balancing or the link load balancing, right? So the server load balancing or the link load balancing is a technology where you ensure that your application is available from a multiple server or from a multiple ISP link or from multiple MPLS link or anything which is from multiple connectivity. Now when we do a server load balancing, we put something called as intelligent monitoring for your backend infra. So it can be your ISP router, it can be your internet link, it can be your MPLS link, or it can be your internal infra, which is the database, app, and the web server. We have few BFSI customers. Basically what they do is they do intelligent monitoring on the backend infra. So most of the times when you design application, you know that this application has been designed to take the load of the 5,000 users, 7,000 users. But you don't have control on the end users. The end user will keep on coming onto your applications. How to avoid the situation where you have reached to your application capacity and you don't want to allow the new users to connect onto that application. Or you want to allow only the platinum types of the user to connect the application, but the any other users which is the normal users, you don't allow them to connect when you reach to a peak of the the capacity of the application. And that is what we do when we monitor the backend infra. When you configure the device, we tell the device that this is a application where you can have a capacity of the 5,000 users. And when I say users, it is nothing to do with the TCP connection, nothing to do with the throughput. It identifies users as a Sheetal, as a other ABC or the XYZ and so on, and then decide whether the number of users or the threshold has been reached or not. And when you reach the threshold, it will take the necessary action. The action can be the redirecting user to somewhere else, or you may want to pop up the message, or you want to say, for example, you are into the BFSI segment, financial goal within 2 years, 5 years, and so on. So when you have a capacity that has been reached, the device can intelligently detect that you have reached the capacity, and now you want to ensure that the user don't go away, stick to your application, but at the same time don't land on the application. So that is what we do with the intelligent monitoring. We can monitor the DB, app, web, anything that is in the app layer, right? Now when we do this intelligently monitoring, Okay, we take the distribution traffic decision depend on different parameters. Now you may have the different servers running the same applications. Even if they have equal capacity, sometimes one of the server runs very slow, and one of the server runs very fast, even if it is having the lot of capacity or the lot of users. And that is where we take the decision where to forward the users. Now this user forwarding phenomena can be very dynamic. They depend on the response time from a backend server. The device then decides which is the best available server and then send the user to that backend server. So it's not only about the monitoring the resource of the backend server or the monitoring the app on the backend server. It's all about on the fly you decide how the server is performing at that moment and then send the user onto that server. So the user gets always the better performance over here, or the user always see the faster performance. And the many times when you do all this load balancing or when you monitor the backend server, you need something called as a session persistency, where the same user comes, he selects something, you want to send the same user to a same backend server. He should not be selected, or the device should not select the server, which is a different server as that where the transition is happening. This is more useful when you have something like the online transition is happening, or when you need a static nature of the application, where the user should again and again go on to the same server till the time the session is live. And this is what we maintain the session or the user sessions. Now the user sessions can be maintained at the different layer. It can be at the L4, it can be at the L7 and so on. So all these decisions that we took, it can be again on the L4, L7, L2, L3 parameters and so on. So what we are trying to say here with the server load balancing or the link load balancing is, over the time period we have developed the technology where on the fly the decision will be taken for best available resource to ensure that the end user gets the best performance at that time. The second functionality which we are going to talk about is application availability from a different data center. Many a times it has been seen that you have multiple data centers, but when there is a rare disaster that happens, you have to initiate the user, or you have to inform the users saying that now don't turn it to DC, turn it to DR. Or you have the TCP IP based application. You have to inform the end user, now this is IP that has been changed, now work from a DR. With the global application availability, what we have developed is from a same URL without knowing the end user that whether he is connecting on the DC1, DC2, if your DC goes down, the app at the DC goes down, the connectivity at the DC goes down, you seamlessly move the user to a DR. So depend on the need, without making any changes anywhere, not at the app layer, not at the DB layer, or not at the URL layer, you can seamlessly move the user from one set of application or the one DC to the other DC. So this is one of the use case that we always talk about, the global application availability, right? Now this is where the other use case is when you have a DC, near DC concept, where your application is running from both the DC, and you want to ensure that your load that distribute across the multiple sites. Any user who comes from a south location, you want to send it to a Chennai. Any user who comes from a north location, you want to send it to a Delhi. Any user who comes from a west location, you want to send it to the Mumbai DC. Your application has been synchronized, and now you want to take the dynamic decision, saying that depend on from where the end user is connecting from, I want to send him to a nearest site which he can reach to, and that's how I improve the performance. So the global application availability is the functionality where you can ensure that the user can connect to multiple data center, a single data center, or seamlessly move from a DC1 to DR and so on. The third functionality is a content switching. This is a functionality where we don't take the decision at the network layer. The decision of the sending the user to backend application will be taken at the layer 7. Again, the very simple example is you have multiple applications coming from internet, app1.abc.com, app2.abc.com, app3.abc.com. It will work if you have multiple IP address, multiple registration that has been done with the ISP. With the L7 content switching, what you can do is on one IP you have all the application up and running, and if the end user type app1.abc.com, it goes on the app1 server. The end user type app2.abc.com, it goes on to the app server 2, and so on. So any content which is onto your URL, URI, into the HTML body, or it can be HTTP header and so on, you can take the decision and then send the user to a specific application server. Most of the times you will find that when you go to a YouTube and the URL, depend on the content, your URI changes and you get connected to a different servers. That is what is all about the content switching, where you can look into a different content and then decide where to send the users, what to do with that content or what to do with that request. Right? So all this about the application availability, where you can deliver the application in the different way from a different servers. Right? Now this is all about when you are running the applications from a backend servers on the different servers. Right? Now the main question comes, now I have built the capacity, I did all this, but there is a surge in the traffic which is coming from outside. During the month end, or maybe during the year end, or during the festive season, you find that there is a lot of hits that is coming on the site. What to do in that scenario, right? Even if you have a lot of infra, you cannot build the infra for maximum peak, or you cannot predict that there is a the peak that is going to happen and my traffic will hit 200%, 300%, and so on. With the surge protection, whenever there is a surge in the traffic, we can hold on the traffic on the nested device till the time your backend resources are not free. You can say that if there is a number of requests going more than this many, then any new request which is coming on the device should be put into the queue on the device itself. And as soon as your backend infra gets free, you should pass this information or this request to a backend server. And that is what the surge protection is all about. In the media industry, any news which is very highly seen by people, this is what the most of the time the people use, the surge protection. You cannot predict how much hits are expected or the requests are expected for that specific types of the content. So the surge protection is a phenomena where the naysayer will build up the queue for a request that is coming for your application, and whenever it sees that the application server has served the previous request, it will push the new request to a backend server. But at the same time, it will hold on the client which is connected to a naysayer device. That means your client will not go away. The client will see a slow performance, but they will not go away. Right? Okay. So in the availability space that we were talking about was more onto the application side. Let me take you to a DB infra side, which is the one of the functionality that we always thought about, which is a unique functionality that we have built on the naysayer device. So what is a database challenge? Let me, before I talk on to the very specifically use case of the database load balancing, let's go back and see what is a database challenge today. You have multiple infra server, you have multiple web server, but till you run the one single DB instance, even if you have a license of the DB, what you do is all the application server get pointed to one active database server, and then you have multiple passive database server where you keep on replicating the database. But you cannot use the passive database server till the time you bring down the active database server. Even if you can read the data from passive database server, the challenge is how to write the data, because the passive don't allow you to write the data. It can allow you to read the data from a DB. And that is what the challenge is. Other is the scalability. You cannot scale the DB if tomorrow the number of users goes up, right? You have to change the DB server with the higher power of the CPU and memory so that you can have more ODBC connection, more DB connection, and so on. The third one is the security. You want to ensure that only the app server connect to a security DB server, or only the specific set of user terms, and then they run the specific queries on the DB server, and so on. These are the few challenges which no one can overcome over the time period, right? With the database load balancing that we have built, what the logic that we put across in the DB load balancing is what we were talking about on the web tier, right? High throughput, high availability, and so on. Can we have a same information or the same thing, the scalability on the DB tier? The most of the people you talk, they will say yes. There are the load balancer available which comes and sit in between app and DB. But the challenge with that load balancer is these are the TCP based load balancer. That means they don't understand the native DB language. They only look in the TCP connection and can then keep on sending the DB query to any of the server which is available. Because of this, it is like having the the TCP based load balancing, where you don't add anything or you don't optimize the DB which is on the backend. The ultimate aim when you do a load balancing, you should able to improve the performance as well as ensure that you have most of the availability on the DB. Because of that, what we have done is we implemented the native DB language on the next error device itself. It's a native database load balancing, where whenever there is a database query which has been sent from an app tier or the web tier to a backend DB server, it looks into the SQL query information. Now imagine a scenario, you have active and passive servers, and you send the read, write, insert, select query to active server, right? Can I look into a native SQL query and say that this is an insert or the commit query, it should go on the active server, but this is a read query or the select query, it should go on the passive server, or it should get split on the active and the passive both. So with the native SQL query or with the native SQL language, what we are trying to do is we look into the database language, and then depend on the need, we move the DB query across the multiple servers. Now the use case is very simple, right? Any transition or any DB that you see, 80% is a read query. The people want to see a report, people want to see their statement, people want to see a server slip, and so on. Only the 20% is the insert or the write query, and that is what the advantage we take. Because of that behavior of the DB over the time period, what we say is now you utilize the DB in such a way that whenever there is a commit insert query, that should go to an active server, but whenever there is a query like the select, read, and so on, it can be split onto the active and the multiple passive server, right? So because of that, the advantage is you can scale up, because on the same active server you have more and more number of users. You can scale out, you can have multiple passive servers, and then you can keep on splitting the query onto that, improve the availability of the application or the DB. And when we do all this, we also do a DB catching, where you can catch the response of the DB query. Most of the times when the people want to see a report, the report is going to remain the same, whether it is gets seen by one user, two user, or the multiple users. And that is what we do when we do a response catch. The data or the response of the DB will be catched on the device or on the memory of the device. Any online site you see, when you do online shopping, right, someone want to see a mobile phone information, when they go and they select, whether I see it or someone else see it, the information is going to remain the same. And that is what we do. Whenever there is a response which can be catched on the device, you can catch it on the next memory itself. And now since it is on the memory, it is far better as compared to the serving it from a backend server. And that is how you improve the performance of the DB. At the same time, you also make that the DB is available in the more faster way as compared to whenever you do the changes. The other use case that the customer implement is you have a DC DR, right? Your DR DB, even if it is a I will say that idle, till you keep on replicating the DB, right? All the log, all the information which is on the DC side is available with the DR side database also, which is a replication by default you set, right? I can use the active DB which is in my data center and the passive DB which is in the DR to fetch the information. So all the read query I can send it to a DR database, where all the write query, insert query I can send it to the DC database itself. So that is how we keep on adding the value onto the DB load balancing itself.
How many active servers you can have?
There is no limit as such. Till the time we are able to see that the server is active, so that is where we keep on sending the query, right? Yeah, it's currently support Oracle 10G, right? The last, the few slides about the IPv6, other than the availability. Now, because of the mandate or because of the multiple reason, the people are migrating on the IPv6. The same device can help you to migrate on the IPv6. So, device you can have IPv6 inside your network, or outside it can be IPv6. It does the multiple functionality for IPv6 native. So when you want to decide, or when you want to migrate from IPv4 to IPv6, you cannot migrate within a day. You have to take the phase-wise approach, where the few of the server will first goes on the IPv6, and the few of servers still run on the IPv4. And that is what we do. We help you to migrate onto the IPv6, where your external can be IPv6, internal can be IPv4, or internal can be a combination of the IPv4, IPv6, and external can be a combination of the IPv4, IPv6. Even we can rewrite the DNS response, which you are getting in the IPv4 format, to IPv6. Because if the query comes in the IPv6, you have to ensure that you provide the IPv6 IP address to a client. And that is what we do. So it's not only about the meeting the application availability on the, the network that you have. In the future, when you want to migrate to IPv6, when you want to achieve the more and more performance, you can use the technology to achieve that. So let me take the few questions on the availability, or the any specific technical question on the any of the part.
How much caching? What is the limitation of caching in the device?
Yeah, so this is a very good question. In fact, I wanted to highlight onto that during the performance, the session. But what we do is we provide the highest RAM on the device. So if you compare with the any other ADC in the market which is available, if the 500 MB they normally provide the 1 GB or the 2 GB RAM, but what we provide is the 8 GB RAM. Okay, so we have a smaller device which comes with the 8 GB RAM, the highest device with the 512 GB RAM, 512 GB RAM. Now the functionality that we provide on the caching is you can allocate 60-70% of the RAM only to cache the content. So depending on the model, you can decide how much cache you want to allocate. And then in the new version that we are going to release, there is a concept of the SSD caching. So we don't have a hard disk on the device. All is a SSD on the device. So with the latest release that we are going to provide in the market, we will have a cache where you can do the caching on the hard disk or the SSD itself, which is as equal to your RAM, and that is how you can have more and more data on the device itself.
Okay.
Right. Any other?
The writing you said was on active database, right?
Yes.
So while reading, it always reads from the DR side?
No, it's configurable parameter. So it on the fly take the decision. So one query may go onto the active database. The second query may go onto the the DR database, or it can be on the passive database, and so on.
Caching is based on SQL statements?
Yes. So we have a few inbuilt policies, and then you can customize the way you want. Say for example, someone want to see the sales report, right? And the same report need to be seen by the other also. So we can set the parameters. If these parameters are common, then you can catch and you can serve it from a memory of the device. Yeah.
It was regarding the database load balancing. So if I have two active databases, and if I write on one of the database, how you manage for the read action? Like it may go on any of the database, right?
Exactly.
So how that is managed?
So we are the replication aware device, where we go and check the status of when the last replication that has been done, and you can set the time that the expected replication time is say 10 minutes. So if there is a query which and if the replication time has not been matched with the active databases, then we will always send the query to a database which says that this has been replicated. This was the last time when it was replicated. So whoever says that the latest time is this, we will ensure that the right query goes onto that server only.
Okay, so the read query will only go to the replicated database.
Yes,
latest
exactly.
replicated
Yes.
database.
So since we do a monitoring before sending any query to a backend infra. Any other question? Sorry? So in the active passive also we monitor the replication when the last time you did a replication. Now you have to decide when you configure the device, right? The passive is, we always consider that the passive has having the same information as that of the active. Okay. Now there is other provision also where you can set the time. So the database query is to see a statement for the last 2 months. Okay. Then we can decide whether to send that query on the active database or the passive database. So these are configurable parameters. where before sending the query to a backend server, we decide or we can check when the replication has been completed, and then we send the query to a backend server.
Log shipping basically the passive node goes on loading, right?
Yes.
So so that passive node will not be accessible, okay, readable.
No, so
in
even
that
if
case,
the
how it
lot
manage?
shipping is happening, till the passive can allow you to read the data. That is what the most of the DB is doing now, where even if there is a lot shipping happening between your active and the passive database, still the passive allow you to read the data, and that is where the lot shipping data even in fact synchronize.
Which version of SQL you are talking about?
2008, 12 both.
I have one question about application availability. This is, as you said, that as the maximum user limit is reached, say 5,000 users, and after that the NetScaler will automatically kind of, it can actually choose users selectively and let some few users pass on and hold on others. So how it is actually achieved?
Okay. So there is two things that we need from a backend application. The information where the application will tell you how to identify the users. It can be depend on the tutti, or it can be a session ID, or something like the username, or something, which information is always present whenever there is a connection live. Okay. Other is how to identify the users, whether that is a platinum user, silver user, bronze user, say for example. So you can provide us the information in the response whether that user is a platinum user or not. Okay. So how we identify is, you can say if you see HTTP header as a P, it is a platinum user. As a B, it is a bronze user. So the some mechanism need to be built on the backend application where we can identify this is a users which is a platinum, bronze, gold, whatever it is, and then we decide what to do with that users once we reach the limit.
So we can do it based on user names also.
Yes.
But
so anything which is present on the HTTP header, so we keep the count of that in our table, and then we keep on building the table for that.
Okay.
So one of the related question to that is the search protection which Sheetal was talking about, right? That is a peak off-peak hour traffic. Suddenly you will find a huge peak which is coming over there. Like that's where the search protection is a functionality which will be very helpful for you, because the user will never get a server timed out error or try again later kind of a scenario, right? So it will be put on a queue, and then one by one on a FIFO basis, these people will get the access to the application environment. So that's what the search protection functionality is all about. Any other questions?
There
Hello.
are two, one is a platinum and
Hello.
one is an ordinary. Both of them come at the same time. Then how does it differentiate?
So you have to configure that parameters, whether you want to put the platinum as a priority or you want to block all the users. So it's configurable parameters. So we have multiple queues, the 4 or 5 queues, where you can say that this is a priority user which I always want to pass. So that is what the most of the BFSI nowadays is looking for, where they don't want to go and put the logic on the backend infra, because all the traffic still goes on the app server, and they want to put the logic in between server or the in between device. That is what we are doing.
Excuse me. What infrastructure changes we have to make in the existing infrastructure to enable this database load balancing?
Okay.
Or the application side changes?
So
we
the
have to
one,
do?
so there is 2 or 3 different ways how we
Okay.
configure the device. One is a transparent mode, where don't make any changes on the backend infra, but we come and sit in between your DB and the app server. Still your app server see the backend infra IP as it is, or the DB IP as it is. Or there is a reverse proxy way, where your app server currently pointed to a DB server, you change it to a virtual IP of the device, and then depend on that we decide where to send the users. In the second approach, there are few benefits, okay? Because when I say few benefits, the troubleshooting become easy. We know where to forward the traffic. If your both the DB goes down on the fly, you can change the DB, but still there is no need to make the app change and all that. So these are the few configurable parameters or the configuration things that you should look into when you do a DB load balancing. Now, if you want to do the very specific catching on the device, then you have to tell the parameters depend on which you want to catch the data on the device itself. So these all are the configurable parameters which we consider during the implementation.
Many to many, right? Many app servers and many queries.
Yeah, many app servers, many DB servers. So other thing that is not only about doing the DB load balancing. Even with the single database that you have, you can reduce the number of connection that is happening with the DB. The ORBC connection eats up lot of memory and the CPU, right? And it's keep on opening the connection, and then once the socket has been opened, it is running long time, right? For each and every user or the query, the app server may open a ORBC connection with the backend DB, and that is what we reduce. The 10,000 app socket may become only 100 app socket or the DB socket on the backend. So even if you have only one server, still you will see a benefit, from a DB load balancing or the data stream as a technology.
Yeah, so just to summarize, we started off with the discussion saying that it's just not only the server availability or the application availability. Netscaler helps you in terms of ensuring the link availability also. Link load balancing, we support MPLS, internet, whatever the different kind of traffic which comes through. All the customers in their data center have multiple links. How do you effectively utilize this in terms of load balancing and make everybody active? In case of failure, the redundancy is being taken care, and that's a part and parcel of the Netscaler solution. And the critical thing is the database. As I said in the beginning, the database load balancing is something very unique, which you have not probably heard, because no other vendor in the industry provides this solution, which is a data stream functionality which Netscaler has, and that's a very critical component as well, because we see a lot of customers, because when you have a web tier, there is 100% there is a DB tier, right? But most of the or all the other vendors only take care of the challenges which you face till the web tier, but nobody talks about the web tier, the DB tier. Between the web and DB traffic, there are a lot of customers who face challenges, whether we support SQL, MySQL, and even the Oracle clustering as well as a part of the overall solution, right? So that's a I think we end up on the availability session, where we talked about in depth on the different load balancing functionalities. So we would, I think, probably take a break and come back for the next session. Rohan?